Automotive Electronics Test 9, and we're basically talking about some electronic stuff here, body computers and whatnot. Technician A says trouble codes will direct the technician to the circuit with a fault. Technician B says trouble codes will locate the exact failure in the circuit. You guys done with, if you guys dealt with trouble codes, everybody here has dealt with trouble codes, right? You've pulled the codes with a scan tool and you've gone and tried to fix something and all that. Can you actually say, regardless of what you're working on, that whenever you pull a trouble code, it's always going to take you right to the problem? It won't, will it? Were you surprised when you learned that? I mean, you knew about trouble codes before, right? You knew that you plugged them in and you got them. They do it at the parts house all the time. But give me an example. You know, most of the engine controls are what most people deal with more than anything else. But I got a story, and I know you guys like my stories. Who likes my stories? Do I see a big show of hands of people who like my stories? Do you learn stuff from my stories? Okay, Cadillac Escalade comes in here, 07, black. She says, my traction control light's on. And so we pulled the codes that got some kind of a network code that had to do with the instrument cluster. You know, and you know the network has got all these modules. They're talking over this multiplex network and all that kind of stuff. And you got more than one network on a lot of cars. You got low speed CAN, high speed CAN, and you got your Class C, Class 2, and you got your PCI on the Chrysler and SCI on the Chrysler, and you know SCP on the Fords and all that sort of stuff. But the long and short of it is, I told her, because we were sort of slammed with a bunch of other stuff and weren't really fooling with anything like that semester. I said, why don't you run that thing over to the Cadillac store? They may have some kind of a reflash for it. I didn't even look it up. I just told her traction control. You know, we were actually doing transmission stuff and or whatever. I don't remember what we were doing, but for some reason or another, we couldn't, you know, give her any satisfaction on that. So she took it to the Cadillac store, the big town, and big town over here, and she called me up and she says, they're telling me that I need a fuel pump because my fuel pressure is too high, and it's going to be $1,800. And so, what do you think about that? I said, well, I don't know, but that sounds kind of peculiar. She said, well, I'm not going to pay them $1,800 to put a fuel pump in this thing. And I said, well, I can't blame you for that. I said, let us just look at it and see what we see. So she brought it back over here. Traction control light's still on, still got the same code in it, some U code for the network. I don't even remember what the code was. So I put a fuel pressure gauge on it, and I got 160 pounds of fuel pressure. It's supposed to be 60. The fuel pressure on that one's regulated inside the tank on a pump. It's in, you know, with the regulator and everything's built right inside the tank. So I said, well, you need a pump for sure. I'm not going to dispute that, but I think we can do it cheaper than $1,800. And so we got her a pump and put it in there and all that. And when I got done, we fired it up and you know, cleared everything out. And the long and the short of it was, I mean, the short version is the fuel pump took care of the network code and the traction control light. What those have to do with each other, I have no clue. I mean, I wish I could give you a long, you know, college instructor thing. Somebody somewhere might be able to do that. All I know is we put a fuel pump in there and fixed the traction control light and got rid of the network code. That goes back to this first question. Technician A says trouble codes will direct the technician to the circuit with the fault. Technician B says trouble codes will locate the exact failure in the circuit. Now, the answer they're wanting here, if you want to get it right, is A. They want to tell you that Technician A is right. I do not agree with Technician A. Right? All right. So, which of the following is an example of a piezoelectric sensor? Oil pressure gauge sending unit, coolant temperature sensor unit, knock sensor, or Hall effect sensor? Now, a piezoelectric sensor has got a piece of quartz in it. What happens when you put voltage into a piece of quartz? It vibrates, right? A little piece of quartz in the watch here. This watch here's got is a quartz watch, and it vibrates at 22,000 beats per second. That's what this watch repairman told me. All right. If you squeeze quartz, what happens? You get voltage out of it. It's really strange stuff. Okay. So if you feed some voltage into a piezoelectric sensor, like a knock sensor, which is what we're talking about here, and there is some additional pressure applied, by the knocking of the engine, it sends out a little waveform on that thing. And whenever the engine controller is looking at the window in which this happens, it knows if it's related to detonation or spark timing or something like that, because there's a certain window of, crank and cam that's looking at. It'll retard the timing usually nowadays on that one cylinder. If that one cylinder is labor knocking, it'll retard the timing on that one cylinder when it comes around. That's why in your scan tool you'll just see that the spark timing they're giving you is for cylinder number 1. So number 2 is B. Technician A says the computer will make control commands to various output devices during the output function. Technician B says the computer uses the input information and compares it to programmed instructions during the processing function. All right, that make any? Who's right about that? Did you guys parse all that data that I just gave you? Will the computer make control commands to various output devices during the output function? Yes or no? Hello? I'm not in here just listening to my own voice. Does that sound right to anybody, or does it not sound right? What do you think?
I'm not sure if it sounds right, but...
So what does your computer at home do? What's the output device? What's the output device on this computer here, Amber? What's the output devices on this computer I'm sitting here looking at? Output devices.
Spring, one of them.
That's good. And printer, speakers?
Yeah, the printer, speakers, spring.
All right, so the computer will make control commands to various output devices during the output function. Yeah, well, that's kind of easy, isn't it? You don't lock down. Okay, got it? Technician B says the computer uses the input information and compares it to program instructions during the processing function. You think that's right?
Sure.
What's programmed instructions? Anybody in here ever even dabble with any kind of computer programming or anything?
So what?
Huh?
What'd you say?
Anybody even dabble with computer programming in here some? All right, now what kind of language did you use when you did that? Remember, was it COBOL or Fortran or BASIC or? Long and the short of it is, you've got, whenever you're doing, when I used to write computer programs, believe it or not, I did. And it was an old language, but I did it just for fun. I didn't do it for pay. And what would happen is you'd have in that particular language, I usually had a data definition area. So you had to tell it what each one of these, variables would be and what they would mean. And when that appeared in your program control instructions, whatever you entered, it would compare. If this value is above this, then perform this. If this value is below that, then do this. If it's between this and this, then do this. That's what we're talking about, right? Trying to get you guys to think. Don't just sit there and wait for me to spoon feed you the next answer. You need to be thinking, okay? All right. Of course, I know everybody has a bad day sometimes, but number 3, both of those guys are right. Hey, Madden.
Yes, sir.
How does it work out when I just hand you the test and hand you the book and say, look these up and answer the questions?
Nowhere near as good.
Yeah. I mean, what happens is you have to dig and read and poke around, and then what happens? A lot of the times the people crash on the test,
Yeah, because the answers on the answer sheet's different sometimes.
Yep, sometimes. That's not always what's wrong, though, A poor workman always blames his answer key. All right, Technician A says positive temperature coefficients to thermistors increase their resistance as the temperature increases. Now, you guys remember when I talked about that in here before? Positive temperature coefficient thermistors. What do? When I say positive temperature coefficient thermistors, I want you to think light bulb, copper wire. And when we're doing this electrical stuff, you can use the EIR. When a light bulb is, before you ever fire up a light bulb, it may have, 2 ohms of resistance. When you fire it up, it's got 6 ohms of resistance because it's positive temperature coefficient. The hotter that filament gets, the higher the resistance goes. All right? So Technician A, he's got his head on straight. Technician B says as the temperature decreases, negative coefficient thermistors reduce their resistance. What are we talking about there? Engine coolant temperature, intake air temperature, transmission oil temperature. Those are negative temperature coefficient. What do? All right. Watch this because you need to know it. Everybody paying attention. I got a sensor here. And it's got little threads and it's got a little bubble down here. And it's got two wires going to it, right? All right. In this bubble, you're either going to have air flowing by there, or you're going to have coolant flowing by there, or you're going to have transmission fluid. Of course, the transmission fluid temperature sensor, it looks like a funky little thing on a wire. But the long and the short of it is, you've got a little capsule there, a little thermocouple thing, if you want to call it that. And right here, you got something, you got two different things going on here. One of these goes where? You remember? All of the sensors, we were talking about that. Signal return, which is basically goes through the computer and it's a ground. It's just a ground that the computer is feeding out. This one here also comes from the computer, but it is going to be 4.6 volts. And in here there's going to be a current limiting resistor in there, which basically means it's going to be reading what's the, it's going to have a resistor here with voltage feeding it, and it's going to be reading from right there. Well, the long and the short of it is, if you unplug this and you measure between here and here, you're going to get about 4.6 volts. That's maximum resistance, right? Which is 40 below zero, is what it's going to read on your scan tool if you unplug that. All right, so you got that, you got 4.6. Now, whenever this starts to get hot, the resistance on it, that's what? If it's negative temperature coefficients, what does the resistance do? As it gets hot, PTC goes this way, NTC goes that way. Got it? Everybody familiar? PTC goes up, NTC goes down. Got me? All right. So, this is NTC. Light bulb wires, other stuff is PTC. All right, so what happens if you've got, what if you had no resistance here? What if I shorted these together? What would I have at my point? I'd have nothing, right? So as this voltage drops, as this resistance goes down, the voltage goes down. If you start it when it's cold, if you're measuring voltage instead of temperature, you're going to see 3 volts or so, depending on how cold it is. As it warms up, it's going to go down. If you're looking at coolant, well, you're going to hit about 0.45 degrees on some of the cars I've looked at when the fan comes on. And what I would do is take, like on a Taurus when I was working on one, I'd back probe the engine coolant temperature sensor and I'd look at that voltage. And I would watch that voltage drop as the engine got warmer. And then when the fan kicked on, I made note of that voltage. And I wrote that down in my little book I carry in my pocket. And then whenever next time I got a Taurus in there, he said, my fan's not coming on. I would poke that little thing in there and I'd watch my meter. And if it got down below 0.45 to about 450 millivolts to about 430, 420, 400, I said, wait a minute, this fan should be on. See where I'm going with that? You find out how it's supposed to do, and you compare it to the one that's given a problem. Okay, but the long and the short of it is, positive temperature coefficient thermistors increase resistance. Negative temperature coefficient thermistors reduce their resistance. So they remember that. They go PTC goes up, NTC goes down. Somebody come up with a memory bug so you can remember that. All right. Which of the following would not be considered a computer input? A, throttle position sensor. B, magnetic pulse generator. C, park neutral switch. Or D, EGR vent solenoid.
C.
Which one?
C.
Is that Bravo or Delta?
C.
Huh? Oh, Delta?
C.
Oh,
Cat.
C?
I say B.
Well, now, isn't the computer looking to see if it's in park or neutral?
I would say B.
So magnetic pulse generator, isn't the computer looking at that? Yes, that's your crank sensor. Is it looking at the throttle position sensor? What sets the EGR vent solenoid apart from the other? The computer is sending a signal out to it, not reading a signal from it, okay? You got me? So that's the one that would not be a computer input. Technician A says a NOT gate simply reverses binary zeros to zeros, binary ones to zeros, and vice versa. You remember the binary code test I gave you early in the semester? Technician B says AND gate operation is similar to two switches in series to a load. What about it? That's actually both A and B. And the AND circuit is the one that you typically see most regularly. What does that mean? On your AND circuit means that, look at this guys, if both of these get a signal, it's going to allow, like if you got something like if there's power, ground, whatever, coming in here or coming in here, it's going to allow it to go out there. But it will not allow this to turn on unless these are both turned on. One or the other can turn on and it won't turn on. You understand why that would be a good thing? Can you say high mount stoplight? Right? High mount stoplight comes on with your stoplights. Right? Although, why would that? I probably just spoke out of turn. If it's an and, that means if one of your stoplights goes off, that one's going to be blinking too, isn't it? No, there's more to that circuit than just an and. One way or another, I may have confused you with that. But a park neutral switch is being tested. When the transmission is placed in the park position, the voltage at the switch is 12 volts. When the transmission is shifted to reverse, the voltage drops to 0 volts. Technician A says the park neutral switch needs to be replaced. Technician B says the park neutral switch is operating correctly. What do you think? What are you thinking about that? I mean, park neutral switch does what? Now, this particular question I don't like, and I don't like it because there's so many different kinds of park neutral switches. But let me ask you about this. I got a starter. And I got this one here that's going through the park neutral switch. It's actually only going to be closed. The park neutral switch is only going to be closed whenever you're in park or neutral, right? All right. Now you're going up here to your ignition switch, which is going to provide start, signal to that through the park neutral switch to the starter, which is going to be like this. You got battery terminal here, and so when this comes through here, if you don't have it in park or neutral, the switch is going to be open. Okay. Now then, I don't know what kind of vehicle they're talking about, but if I'm looking at this and I've got it in park or neutral, and I'm measuring this right here, what should I read? This is not closed. I'm not spinning the starter. What should I read right here? Should I read power or should I read ground? Remember, this big old thing down here is grounded. That solenoid is grounded to this. So this ground should travel through here, and should light my test light or tell my meter I got a ground or whatever. I don't like doing this with a meter, but when I energize that, this ground is neutralized, but the PCM is looking at this. Why does the PCM need to know that? Why does it need to know when you're in park and neutral? Everybody. Huh? Well, not that. I mean, basically, there's a different part of the switch that operates the. Although the body computer on some vehicles may look at that and tell the backup lights to come on, so you may be not quite so far off there. But one way or another, the engine controller is going to want to know if you're in park or neutral. On some of the ones that I worked on early on, they wanted to know if you were in park or neutral so that they know what to do with the ignition timing. And if you're in park or neutral, it has a difference in idle speed control, works differently and all that kind of thing. But one way or another, rather than mince a lot of words about that one, basically going to tell you that they're wanting you to say B, C. See, they're giving you not enough information to give you a good answer to this question. When the transmission is placed in the park position, they don't tell you what kind of car it is. They don't tell you how the circuit's wired up. You don't have a schematic or anything. I don't like this question. If this kind of question right here, you would never see a question like this, or you would never see this question on the ASC test because the ASC questions are typically more fair than this. This one here is kind of like, what? So just put a B there. What is the Wheatstone bridge used to measure? Adam, have you heard of a Wheatstone bridge?
No.
It's basically supposed to measure pressure, temperature, mechanical strain, all of the above. It's a kind of circuit. Whenever you got computers that are interfacing with the real world, they're going to have ways of measuring things. And so that they had to come up with things to, had to invent things to measure stuff. Technician A says the output of a Hall effect sensor can be checked with an AC voltmeter. Technician B says the output of a magnetic pulse generator can be tested with a lab scope. All right. Now, can you check the output of a Hall effect sensor with an AC voltmeter? I don't like that, because what does a Hall effect switch do? You remember the little distributor I got over there on that board that I had laying out there? And it's got these little windows that goes between a magnet and a little piece of electronics. And it's reading like this. That's the kind of signal it's putting out. All right, this is 0, and this would be either 12 volts or 5 volts or whatever. But are you going to be able to read this with an AC voltmeter? I don't think so. However, the output of a magnetic pulse generator, how many of you guys have done that? How many of you guys have taken a lab scope and measured the output of a magnetic pulse generator? Think about it. Remember the one early in the semester in electronics, you hooked the scope up to the wheel speed sensor and you got this. Remember that? That's what this is talking about. Put it together. Okay. Did you do that?
I'm not sure.
Did you turn in the sheet? I thought so. All right, let me see here. Technician A says the output of one computer can also be used as an input to another. You think that's true? Hey guys, we're talking multiplexing here, right? Technician B says a sensor is an output device. Is a sensor an output device? What does a sensor do? What is the word? Give me the word. What does a sensor do? It starts with an S. Senses. So if it senses, is it an output or is it an input? Is your keyboard an output or is it an input?
Input.
It's an input. That's right. You should know the answer to that one by now, right? All right. Now then, Technician A says, random access memory will store temporary information that can be read from or written to by the MP. Technician B says, read-only memory can be written to and changed by the computer. What's MP? Did you go blank? Anybody know what MP is? Tell me what MP is, somebody.
Is it memory processor?
Close. Microprocessor. Or CPU if you want to call it that. All right, so number 11 is basically A. Read-only memory cannot be written to and changed by the computer. Now they do have, if you've got EPROM, or actually EPROM, that's erasable programmable read-only memory. There's Sonia. Let me see what she's got. Hey Sonia, what's up? Yeah, the Lexus. Okay, let me call you back with that because as soon as I finish with this class, and I will let you know. All right, bye. All right, now then, so number 11 is basically A. But EEPROM is what you juice up your EEPROM in the computer on the reflashable ones with 18 volts, and it wipes it out, and then you rewrite it. So, that's basically programmable read-only memory there, but it's erasable programmable read-only memory. Technician A says non-volatile random access memory will lose its memory if removed from its power source. Is that true?
Yeah, sometimes.
Seriously?
I'm not really sure.
Technician B says volatile random access memory is erased when it's disconnected from its power source. Who's correct? Give me an example of non-volatile random access memory, because it won't lose its memory. Non-volatile means it won't lose its memory. So why would you even need that? Think about it. What if I took my battery cable loose and then I went back and I looked at my odometer and it was reading that I had 0 miles on the car? That would be a breach of federal law, wouldn't it? Now, you will lose your trip mileage. That's volatile. Your trip meter, you know, that said you've driven from grandma's house and it's 88 miles or whatever, you take your battery cable off, that one's going to dump. That's volatile. Non-volatile is the one that doesn't lose its memory no matter what you do. You can't make that one go away, all right? Let's see. So number 12 is basically going to be D. Technician A says electrostatic discharge will destroy a prom chip. Technician B says installing a prom chip backwards will immediately destroy the chip. Who's correct about that? That's C. That is actually a question that's sort of antiquated because you don't put prom chips in anything anymore. But General Motors cars used to have a little centipede prom chip you had to move from one engine controller to the other if you were changing out the PCM. And electrostatic discharge, you know, when you scuff your feet across the rug and you touch something and it pops, you've actually put out 25,000 volts, 8 to 25,000, and you can destroy something that way. You won't usually, but there's a lot at stake there, so be careful. Technician A says high side drivers control the ground side of the circuit. Technician B says high side drivers may be capable of determining circuit faults. All right, to begin with, you got to know what a high side driver is. High side's going to be the one that delivers voltage. Low side's going to be the one that delivers ground. If it's delivering ground, it's a low side driver. If it's delivering voltage, it's a high side driver. And so 14 is B. Sometimes the drivers are, you know, hooked into a circuit that will tell you if there's a problem there. Here's another thing. You see these codes on these vehicles that talk about, they'll have a code that's, it says performance fault, right? And so what that means is whenever it's looking at the voltage that's being fed into the hardwired side of the sensor, and it's coming to the PCM, and the PCM energizes that by grounding the other side of this, well, it's an actuator, not a sensor. Okay, so it grounds the other side. It's looking for that 12 volts to be there when it's not got it grounded. If that 12 volts is not there, it knows that sensor's open. Now, if it doesn't see a problem electrically, but it's looking at something else, if I say, I've energized this transmission solenoid, but this thing's not going into third gear, then I know that I've got a performance fault. It's not an electrical fault. It means that the solenoid is not doing what it's supposed to do as far as I can tell. That's the way I always saw performance fault. Correct me if I'm wrong. Okay, which of the following would represent the number 255 in binary code?
D.
That's going to be B, isn't it? Yeah. Which of the following is responsible for sequential sampling? That's a complicated question if you didn't read the chapter, isn't it? What you got? MUX. A lot of this stuff you don't really need to know to fix a car, you know. Technician A says the microprocessor commands actuators output by output drivers, which is like a transistor. Technician B says the outputs are never controlled by supplying voltage to the actuator. The word never is totally off the chain red flag for me. I don't like that. All right, hang on just a second. Hey, Donna. Yeah. Yeah, we got it on the lift right now, and we tightened the transmission oil pan just a little. It was like a quarter of a turn on each bolt. And we dried it off. We're going to see if it's leaking anymore. That's what we're doing now. Oh yeah, that's part of the project. All right. Let's see. Now this right here. See this guy right here. This question here, according to this answer key, says Technician B says outputs are never controlled by supplying voltage to the actuator. That's hogwash. However, that's the question the answer key is looking for, right? I mean, I don't like that. It's just the way it is. I mean, that's what they say. But I can give several examples of engine controllers, transmission controllers and stuff, body controllers supplying voltage to an actuator. As a matter of fact, the injectors were driven by voltage on the 87 and 90 model Jeep Cherokees. Put B there to get it right, but I'm telling you, that is a bad question, and I don't like the way it's worded. Somebody needs to be worked on about that and smacked around. All right. Okay, Technician A says circuit testing of the BCM power supply will indicate if there's high resistance in the circuit. BCM power supply. Technician B says open circuit testing has the potential to mislead to improper diagnostics. That's actually C, but let me tell you about this. Here's a little rule of thumb when you're doing electronic stuff. And we're not going to be system specific here, but let's say that we've plugged in our our scan tool, and we've actually looked at all of the stuff on the vehicle, right? In other words, you can do that with the IDS. You can also do it with that Autel MaxiDOS. You can do it with, even if you got an OTC Genesis, you can just tell it to check all the engine controller. It talks to every controller on the car while you go get a cup of coffee, and when you come back, it tells you who's talking and who's not, right? Now, if it's squawking and saying, I don't hear anything from ABS, or I don't hear anything from automatic temperature control, and it's not equipped with that, then you've solved that mystery right there. But what if you have ABS? What if you've got an ABS light? What if it can't talk to the ABS? Well, you got an issue with that, right? So now you got to go to your ABS box. You go to your ABS module. And your ABS module got a bunch of wires coming to it. Okay, you got wires coming to it for power and ground. You got wires going out to wheel speed sensors, or actually coming in from wheel speed sensors. And if it's got a separate hydraulic control unit, you got wires going out to the actuator and all that. The long and short of it is, here, think about this. The first thing I'm going to check is B plus and B minus. I'm going to find the powers and grounds. I'm going to make sure I got powers and grounds. If I've got powers and grounds, but that module's asleep, and the network is not shorted, pinched or something, then I've got the idea that I got a bad box. If the module's not doing what it's supposed to do, but it's got power and ground, basic rule of thumb is suspect the module. Don't throw one on it until you're sure that the network that it's trying to talk to everything else with is not pinched against the ground somewhere, but that'll usually take down the whole network. All right, so I just wanted to cover that right quick while I was thinking about it, because it's pretty important stuff here. Technician, he says a pulse width modulated actuator cannot be tested with a digital multimeter. Technician, he says a pulse width modulated actuator may be tested with a lab scope. B, you know, you can test a pulse width modulated actuator with a digital multimeter. High side controlled actuator fails to operate. In other words, high side control means what? The positive side is what the actuator is switching. The scan tool displays 0 amps on the control circuit when the system's turned on. Technician B says this may indicate a short to ground in the circuit. Who's correct to that?
There is no technician A saying anything about anything.
Yeah, you're right. The scan. how you going to do something? See, that's another poorly written question, right? The scan tool displays 0 amps on the control circuit. Just so you'll get it ready, get it right when she grades it, put a C down there. We don't know what technician A said, but whatever it said, he was right, because he's not even there. He was paying attention to that, wasn't he? Okay, now, the relay coil circuit is controlled by a low side driver. Direct battery feeds connected to the other terminal of the coil. If the BCM monitors voltage on the control circuit to determine proper operation, which of the following statements is not true? Now, that's a long question. I don't really like these. A, the voltage reading by the PCM before the low side driver should be battery voltage with the coil turned off. The voltage reading by the BCM before the low side driver should be close to 0 volts with the coil turned on. A constant low voltage reading by the BCM may be the result of an open in the circuit between the battery and the coil, or finally, the BCM will not be capable of setting control circuit faults. Now, the constant low voltage reading by the BCM may be the result of an open circuit between the battery and the coil. Okay, what were we talking about? Let's do this. All right, I got to do this stuff. You guys be ready. All right, see here? All right, now we've got sensors here. Let's say we got 4 wheel speed sensors. All right, and then we've got actuators here. I'm just going to put a couple of actuators. Now we got 2 wires going to each one of these, and we got 2 wires going to these. Well, typically, this wire on these is going to be fed not from the engine controller, but it'll be fed from a relay. And it'll be going to the same relay. So power comes in here, and it controls these little actuators with ground. All right, that's why I said earlier, if you're measuring right here, and this is powered, but the controller doesn't have it grounded, the controller is going to expect to see 12 volts on these wires right here when it doesn't have those grounded. If you've cut a wire, are you going to see 12 volts there? No. If it's shorted to ground, or the actuator's unplugged, or the coil's burned out, you're not going to see 12 volts either. That's a control circuit fault. Everybody familiar with that? Everybody understand what I'm talking about here? This is extremely important, because you got to have a really sharp understanding of this where you can fix anything. I mean, this all seems like hooey when you're in the classroom, but when you're all higging on one and you got to figure out what's wrong without anybody giving you a hand, you know, this ain't funny. It also sends a little whisper of voltage out to each wheel speed sensor when you fire it up to see if it's got a continuous loop. You know something else? On some vehicles, it gets a little whisper of voltage. The module shoots a whisper of voltage out and sees if it comes back on the other side. Airbag. And there was a guy that put his ignition switch in his little Geo Metro or whatever it was. He put an ignition switch in it and he pinched one of the wires going to the airbag. And it just so happened he pinched the one that was supposed to be the ground side. And whenever he turned on the key and that module sent that voltage out to the airbag, it came back and found ground on the other side. And it goes boom, and it was like a boxing glove hitting him in the face when he turned. He came in there to get another airbag from the dealership, and he had a great big raspberry on the side of his face where the thing punched him. You know, I mean, what I'm saying is that a lot of the time, they program these engine controllers, shoot a little bit of current out, and see if it comes back on the other leg. That's just the way they do that. Okay. So number 21 is going to be Charlie. An actuator that receives direct battery feed and is controlled by a low side driver has a short to ground in the control circuit. Technician A says this may cause battery drain. You think? Think it will? If it receives direct battery feed and is controlled by a shorted low side driver or a driver that's got a short on the wire going to it, can that kill the battery? Can it or can it not? It's an actuator, right? It's going to be a little solenoid. It's going to have wires in it. Heck, it may even be a relay. It's going to pull a little bit of current, isn't it? That little bit of current that it pulls is like having you can have a 55-gallon drum full of water, and if you've got a little hole in it, and you leave it sitting there very long, it's going to be empty, isn't it? Okay, figure it out. I'm going to ask that question again. An actuator that receives direct battery feed and is controlled by a low side driver that has a short to ground in the control circuit, will that kill the battery?
That is a short to the ground, but not.
Because it may cause the battery to drain overnight. So what you got is you got B plus coming in, and you got your actuator here. It's got a coil of wire in it, and then you got a controller here that's supposed to send it around out when that thing's supposed to be working. And this is shorted to ground. What do you have there? You've got current flowing through that battery, that wire, flowing through that actuator, going to ground right here. And is it possible that that may kill the battery sitting overnight?
Yeah.
All right. Why was it so hard to get a yes out of anybody on that? Okay. Technician B says the BCM will no longer have control of the system and may set a diagnostic trouble code. And that's typically the way that works. If the BCM picks up on a short to ground, it typically goes to sleep on a lot of these circuits. And that's another generality that, you know, is kind of spooky. The flashing of a computer is done to perform which task? Say that again? Which one?
B.
To update the software within the computer to correct or enhance operation. And what you're thinking, and you're thinking accurately, is BIOS flash. When you're flashing a BIOS on your computer, you're doing the same thing. Let me give you some examples of flashing. And this is theory class, and I'm supposed to tell you this stuff. If I don't tell you this stuff, I'm remiss, okay? Okay, whenever they used to have, like, whenever the torque converter would go in a full lockup, and you would be cruising along in fourth gear with full torque converter lockup, some of these cars that we were selling back whenever I was, you know, flashing stuff, would be shuddering. You know how you've driven a standard and you got it in too high of a gear too soon, and it's that's what it feels like. And customers didn't like that, and so it went up the pipeline to the engineers, and they said, we don't like this, and so they determined, they drove the car. All of them were doing it. That's another thing. It wasn't a malfunction. It was a, you know, design flaw. So all of them were doing it. So what they did was they retyped the algorithm to prevent the torque converter from going into lockup until it hit 50 miles an hour. And what they did was it was higher up in the engine's torque band, and it stopped it from doing that stuff. Well, there was another one. These guys brought me this diesel Dodge pickup that had an electronically controlled transmission, and it had a throttle position sensor on there that was for the transmission. And they said, this guy's wanting to buy this thing. This was a used car department. And they said it's hunting in and out of gear when he drives down the road in high speed. I mean, like, road speeds. It's hunting in and out of fourth gear. And he says he's really spooked about that. And if we can fix this car today, he'll buy it. But if we can't, he's going to buy one somewhere else. No pressure, you know what I'm saying? So they brought it in there, and they said the transmission shop said put a throttle position sensor on it. If that didn't work, they'd have to tear the transmission apart. And so they brought me a throttle position sensor with it, and it didn't fit. It wasn't the right one. And so I said, let me just plug the MDS into this thing and see what it says. And so the MDS was a big computer that stood over against the wall, and there was the scan tool, which was the DRB3. We'd plug it in under the dash, and it was a bridge. The scan tool was a bridge between Chrysler's computer network and the vehicle. All right, so as soon as you plugged the DRB3 in, it knew the serial number of the car. It knew the number, the revision level on all of the engine controller. The controllers that were on the car, and this one just had a transmission controller. And it threw me a message, when we went into the session, and it said, there is a transmission controller reflash available for this one. Are you interested in knowing what it's for? And I said, yeah, sure. So I clicked on what it was for, and it said this transmission reflashes to address a condition where it hunts in and out of gear going down the road, which is exactly what they were talking about. And so it says, do you want to reflash to this new cal? You don't just go in there and randomly reflash just for the heck of reflashing. So you're supposed to actually target a problem, and that's what I was doing. And I said, let's go ahead and reflash it. And so I told the DRB3 to do the reflash. And whenever it wiped out what was in there with this little 18-volt surge, and it wrote everything back in there, and they drove that truck down the road. I never even drove the truck. They were the ones complaining about it. And I called the salesman. I said, go get it. Come get it and see what it thinks. And he came back. The guy bought the truck, and when the salesman came back, he also brought me a $25 gift certificate to Longhorn Steakhouse. Because the thing about it is they got a sale out of it because of the fact that we were able to fix it really quick. See, but that's what a reflash is about. Sometimes you'll have vehicles that are stalling during parking lot maneuvers, or you'll have emission standards that aren't quite being met. That's what reflashes are about. We can actually reflash with some of the equipment we've got here, too. So, we've done some flashing. See that thing behind you? Right over, pick up that gray thing with the buttons on it that looks like power window switches. See that? All right, let him hold that up. Everybody see that? That's off of a 2002 Trailblazer, right? That's an old vehicle. Power windows were doing crazy stuff. It was going click, 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 and the window would go up and down by itself and just crazy things. And the girl came over here and she goes, this is driving me batty. What do we do about this? And I said, well, it needs one of these things. So we took that one off and got one, $125 from the dealership up here, plugged it in, and the windows didn't work at all. And what we had to do was we had to flash it. We had to actually configure it for that vehicle before it was usable. That makes sense? So that's more than a power window switch. It's a computer. And a lot of the times what you're looking at here, it's got your power window switches on it and all in these newer model cars. Not every time, but a lot of times you're looking at a driver door module or a computer or something that's got to be, there's more of that. You can actually, like on these 05 Dodge Caravans, or they've got all kinds of stuff like that. Now then, let's see. Which method may be used to check a computer-controlled actuator?
D.
You can actually use ammeter, yeah, all of the above. That would be a good answer on that one. Now I got one more question here, and then we'll be done. When measuring the voltage on the power feed circuit of the computer, the voltage reads 12 volts with the connector unplugged. When load tested with a test light, the meter reads 12 volts. When the connector is plugged back in and back probed, the connector reads 9.5 volts. Technician A says this may be due to an internal problem in the computer. Technician B says this may be due to an open computer ground circuit. All right, power feed circuit to the computer. What are we talking about here? You unplug the connector, and you're reading 12 volts at the connector. All right, you load test it with a test light. You read 12 volts. That's with a voltmeter. Now, you're reading the voltage while you're hooking the test light to it to see if the test light pulls the voltage down. If you're still reading 12 volts, you're you know that you got plenty there. When the connector is plugged back in and back probed, it reads 9.5 volts. Technician A says maybe due to an internal problem with the computer. What do you think about that? Open computer ground circuit?
A.
Yeah, I'm bothered by that question right there. A would sound like a feasible answer to me. I mean, just personally, I would think A would sound like a feasible answer. That's not likely to be a ground circuit problem either. But if you want to get that one right, put D. I'm not sure I like that answer, but put D anyway because she's going to grade your test. Even though we go over the test in here, she grades the tests question by question. And it's really surprising how many questions are missed. Maybe because I'm not doing a good job of, explaining things, but whatever. But anybody got some questions?